Marios Logothetis from Intrasoft International. I'm working at R&D department as a senior innovation and research manager. And I have a few slides about the approach and the architecture that we had during the Track and Know project. So before starting with the description of the approach, I would like just to mention some of the challenges and the businesses that we have identified during, let's say, the first design of the platform. So the first one was that we identify a shift in the software development ecosystem, meaning that now from a complex coding, we find that we have to create, to design and develop software solutions that are going to handle large amounts of data. So as we call it, big data. So this was one of the challenges that we identified, and also having in mind what is the terminology of the big data, we were able to design a data streaming and analytics platform where we actually decouple the complexity of the data sources from the databases and the data processing algorithms. So we built a data streaming platform where some of the characteristics was that it was real-time monitoring and device processing. We were talking about the distributed message system platform. And one of the two, let's say, main characteristics was also that it was high scalable and with a high fault tolerance. So this is a detail, I could say, architecture of the Track and Know platform. First of all, I would say that at the middle where you see it's the data management solution, which actually was the Track and Know platform. And with that platform, which is based on open source and Kafka technologies, we were able to ingest large amount of data coming from different data sources. And when I say different data sources, could be any data stream coming from an IoT device, or could be also a connector with batch data or databases in general. So for different data sources, we will be able to create some connectors in order to ingest those data to our streaming core platform. Just to mention, our streaming core platform, as I told you, was a distributed platform. So we were able to create 16 virtual machines in order to handle those large data. And at the right side, you can see that where actually there are the data analytics part and the visualization part, where the other presenters are going to present next what they have done. Just to sum up with the platform, just some of the characteristics. As I told you, it was a distributed streaming platform for handling and ingesting real-time data. It was based on the Apache Kafka, which is an open source. And some of the major key capabilities of the platform was, again, that it was real time. We were able to, in real time, monitor any type of event. It was able to interoperate with all modern data storage technologies. Of course, one of, let's say, major here characteristics was that the security. So we were able to develop and some of the mechanisms in order to achieve the encryption, authentication, and the authorization. Apart from that, what we also identify is that we were able to use that type of platform in order to automate the end-to-end life cycle of the machine learning applications. And when we say continuous delivery of the machine learning, we have in mind three specific things. The first one, that we were able, with that ingestion of the data and actually forwarding the data to processing infrastructure as the Hadoop cluster, we were able to model train and to validate the models. Then we were able, with the VES platform, to inference the model or in the edge or in the cloud, depending where we would like to execute an ML application. And the third one was that with that platform, we were able to monitor real-time the model, and with specific APIs to have alerts and to improve again the machine learning based on specific outcomes of the machine learning model. So as I already told you, we have, this is a system architecture at the right, and that's what we had implemented during the Tracking project. As I told you, we have deployed that platform in 16 virtual machines. And just as a final slide from my presentation was where we think that this type of platform can also can also support other use cases apart from those that we were dealing in Tracking. The first one, as I already told you, and we are again using that, is for real-time monitoring and in general collecting any type of metrics and alerts. Some examples of the industry that are using for that purpose, you can see is Netflix or an Airbnb. The second use case, which is actually where it all happened with the Kafka and started, was by LinkedIn, where actually introduced Kafka to the industry, and the main purpose was to create message queues in the content feeds and a typical public subscribe system. Another use case is the analytics and any real-time X functionality that you can have, for example, processing or visualization. And last but not least, such type of platforms can facilitate the distributed data center and the distributed log system. Thank you very much for